right, welcome to our round of comments, I guess. So, what I wanted to do is go through a good amount on the scientific process because there's one particular thing that I'm seeing. So, check this out. Let's see if we can do some drawing. Imagine that you are looking at something right now and there's nothing. All right, perfect. So, let's try that again. Three, two, one, go. Imagine that you are looking at something, and imagine that this is the globe right here, and all of its complicated processes. So think about the physical processes that are on our scale, things like me looking at this pen and looking at this screen, but then also microscopic processes that are currently causing certain kinds of things in me. So you can think about endocrine responses, epigenetic profiles, gut bacteria, whatever, it doesn't really matter. And there's a lot of stuff here. There's just a ton of stuff. One of the main things that we have to do in science, so imagine that you're looking at the phenomena, or, this is just a fancy way of saying the objects of our experience. Now, the question is, are these objects independent of our experience, or are they somehow relational to our experience? That's for another kind of class. You can call these real systems. These are things that we are concerned with. One of the difficult tasks is when we are trying to represent the world. And think about this in terms of we want to explain the world, all of its intricacies. We want to predict the world, and then we want to also do things like intervene and maybe modify, but that's for a little bit later. So we want to represent the world. The thing that we have to do is imagine that we are doing something like constructing a model. Now, when we say model, we can also talk about theory, hypothesis. What we want to do is pick out certain things in the world, and we want to represent those things. Moreover, we want to not only represent these things as, let's say, variables, so this right here, say variable 2, variable 1. These things can be anything. It can be anything like, why do I get emotional when I see a sunset or something like that? So one of the variables is a sunset, let's say like here, and then the other thing is, this is my eye right here, and me getting emotional some of the time, but I don't tell anyone about it. I also want to know the relation between these two things. That is, I want to know the causal process here. Is it something where I am inspired? Let's say that it has an aesthetic mechanism. Is it something where it's like when I see the sun, because, maybe I'm perhaps some sort of a vampire. I am recording this lecture kind of late right now. Perhaps it's something to do with physical processes that are beyond my control. So there's some sort of physiological chemical mechanism that makes my tear ducts produce tears, and it has nothing to do with feeling sadness at all or feeling touched. So I want to know these relations. And the thing that's really important here is we have to specify. We have to specify variables, and we have to specify the relations. And oftentimes what's going to happen when we're doing this process is we're going to leave a whole bunch of stuff out. So what that means is a lot of stuff will continue to be in question. We just won't know how to deal with that stuff. That's for other models, so we can continue this modeling process. I mean, you can really think about this as continuing forever. And each of these models are going to be limited to aspects and degrees. And why I wanted to say this is because if we don't limit our models, we can get things like this, which is super cool. I mean, so check this out. This is like a screenshot of a VHS tape. So basically right here, this is from Jeremy Deller, and it's The History of the World, 1997. When was that even? So this is what's really cool about this whole picture. Whoops, I don't know what that is it shows all of these complicated relations between cultural music scenes, and it's not just the bands themselves, but it's also the events and the people that are entangled with those events. And there's so much stuff that's going on here. Some of these things, I don't even know if these are bands or like states of mind. So there's like brass bands here, melancholy. I guess these are bands. I do know this, if you zoom in right here, this right here, Kraftwerk, Very cool. I mean, if you have like maybe 2 hours or you want to, kind of just get a little bit funky, YouTube this. This is actually Kraftwerk. Is in this famous scene from the movie Breakin'. I think it actually might be Breakin' 2, but I don't know why I would know that. But it's this super cool pop and lock scene where, like, if you got some time, maybe pick up a broom and start pop and locking and do some cool stuff. But
Anyway, Fred Astaire. Who? Just go on to sweep, knucklehead.
basically, this right here, why I wanted to show you this whole diagram, is there's a lot of really cool stuff going on, and most likely there are meaningful relations that are somehow indicated by these kinds of arrows. But we don't know what's going on. Number one, there are too many variables, so consider all of these bands as a lot of variables that we're dealing with, and that's fine. But if we want to be explanatorily precise, we have to limit the variables and we have to limit the relations. It's super important. So one of the things that I wanted to also talk about is, let's just go back to this picture right here. Not only do we have to pick and choose how we model certain things, these are our representations within models, but we also have to pick and choose, and let me just do a little bit of erasing for the ease of purpose here. So let's just get the erase tool. I wonder where these things go when they're being erased. You know, I think it was like Leibniz or someone who had this theory of things in the nothing, like it's like this realm of the nothingness. That's not even how you spell it. I think it's something, imagine this like realm of the nothing. And these things are somehow, I don't even know how this works. I think I'm getting all this wrong, but there's all this like really cool literature on the nothingness. And these things, even though they're nothings, are somehow interacting and competing in order to get into the realm of existence. You know, you can think about this as like the realm of something. So it's actually, this is kind of funky. Okay, so let me put these things back into the nothingness real fast. Research suggests that the anterior cingulate cortex burns out every 3 to 4 minutes, so this is why I get kind of funky and go into these stories, is because we all need a cognitive break sometimes. So back to the picture. Not only are we to be selective on the model side, but imagine that what we have to do is get data from the world. That means we have to actually go out and collect this data. We have to do things like observe. We have to ask people questions. We have to survey people. We also have to do things like intervene. Now, this is really interesting because there are these discrepancies between how we observe people doing certain things and then how we intervene to find out things like the truth. So I don't know if you all know the Milgram experiments. These are really kind of controversial and super funky. This is basically when, imagine that you're a participant in this experiment, you are asked to go into this room, and it's like, okay, cool. So what you're going to do is you're going to sit down and you are going to be in charge of reading this script, and it's got a whole bunch of word tasks, and then there's this other person within a different kind of room, and this person right here is going to, let's say that there's, you know, like a microphone or something like that, and this person is going to give answers, and when this person gets the answers wrong, this is horrible. This person will be electrically shocked. I mean, it's not with lightning, but this is just kind of for massive effect. this person's going to be electrically shocked. And here's the thing, the voltmeter is actually going to keep on being raised. And this right here is a person who's an actor. So they're not actually being shocked, LOL. It's something that the experimenters failed to tell these people. But moreover, what's going on here is there's this person who is standing here and they have this lab coat. Let's say the lab coat is very important. So this person is supposed to be, kind of like an expert, a professional, a doctor. And this person makes commands. And so let's say when the actor gets a question wrong, you are actually supposed to be in charge. So think about this as like you are now causing pain, you are causing suffering within this person. And most people, if you ask them, so if you just do pure observation, you say like, okay, if you were put in this scenario where someone was commanding you to shock someone, would you do it? And most people would be like, no way. Like, there's no way that I would do something like that. But what they actually found is that something like 65% of people would go all the way up to lethal levels of shocking this person when they are commanded by an authority figure. And this authority figure had to be in a white lab coat. That was a very important thing. Like, you can't be in a jean jacket or something like that. It doesn't work. So what's really interesting here is we get totally different data between observation and intervention. If you just observe people, just ask people questions, you survey people, but when you diabolically intervene, I mean, this right here is actually something that we have to be very careful about in cognitive science, because these people could actually walk out and develop things like PTSD. I mean, that's not how you spell it at all. Talking and writing is sometimes very difficult. This is all happening live, by the way. So PTSD is something that is a massively horrendous thing to experience if you've had loved ones, if you have experienced it yourself. It's absolutely devastating. So this is not something that you want to produce as a function of a psychological experiment. So the experiment is an important social experiment. I mean, this is actually something that Milgram thought up after the Nuremberg trials happened and Nazi war criminals were asked, why did you do something? And they were like, well, I was told to do it. I was told to create horrendous suffering in the world. And so Milgram was like, wait a minute, you can just tell people things and they'll do it. You can shout commands at people and they'll make other people suffer. And it seems like his various replications of the experiment, I mean, this is all the way up to like 30 some replications where he varied so many different things. He eliminated this person in a white lab coat, like I said. The clothing type, the types of commands are super important here, because some of the commands were like, it's important that you continue. So it's like, just, for the purposes of this experiment, it's really important that you continue. And then people, for the most part, would continue. And other commands were like, please continue because of some sort of, I don't even remember what the other commands were like, because it doesn't even matter. The super important command is, this is the one that was really a difference maker. You have no choice but to continue. Because the other commands, and that is not at all how you spell continue. The other commands leading up to it, I think it was 4 different types of commands. Let me see if I can just quickly access my consciousness. So it's like, please continue. It is important for the purpose of this experiment that you continue. Some sort of third one, and then you have no choice but to continue. And this is the most mind-blowing part. When people are told you have no choice, you take away their autonomy, 0% continue. Anytime this command was uttered in any replication of the experiment, people were just like, you know what? I do have a choice. I'm out of here. So what's really interesting is that the Milgram obedience experiments were about how people obey. So this is like that whole, it's from the movie They Live, where you see these signs and they're just like, obey. But what they found is that if you take away people's autonomy, they will actually disobey. So what that means is, if you say, look, you have no choice, like this, your autonomy is gone, then people will actually disobey. So the reason stated for people obeying in this horrendous intervention is that they thought this was socially important. That was at least what they said after the experiment. Now, notice what's really important here is here you're mixing this like really devastating diabolical intervention with some surveying and some observation after. You're asking people, why would you do something like this? And you say something like, well, yeah, I think it's a socially important thing. So perhaps the observation is false. So overall, the reason why I detoured into this is because you have different ways of taking data. You know what? Let's make this a little bit more robust. You have different ways of taking data. Moreover, you have different things that you can take data on. You have a choice in what types of variables you focus on. I don't like that at all. 1 second. Whoa, it's erasing without me even doing anything. Technology, y'all. Yes. What year is this? We're still trying to figure out how to erase on a computer. I remember when it was 1995 and I first got MS Paint. Actually, no, you know what? I used it somewhere else and I was so blown away by MS Paint. I was like, you can actually draw on a computer? This is incredible. And the drawings just look like, well, you know. All right, so check this out. You have to choose which variables. And not only are you choosing the variable type, so think about this as like, well, what kind of choices do you have? You have choices about the variable type. But then you also have choices about how to take data. Moreover, you have choices about how to organize data. I mean, there's really so much to choose from. So keep these choices in mind. And I have a couple of, just silly ones. And this is obviously where all sorts of things happen on Reddit. There's a subreddit called Data is Beautiful. This is where I sound like I'm like 80 years old. I'm like, there's this thing. And Data is Beautiful has some really interesting things. I mean, this one is like really kind of a tricky one for us to analyze. This is causes of 2020 California fires by area burn. And right here, a lot of people are really angry about the gender reveal party that caused a massive amount. This is 12,000 acres being burnt. And then what we see, this is like, oh my gosh. I mean, the kind of state that we're in right now. I don't know if you all have seen this. I mean, I don't know where you are and exactly what the air quality is like, but some people actually made this comparison between Blade Runner, and this is 2049, and San Francisco. So they did this drone footage and they put it to Blade Runner music. And when you take a look at stuff like this, I mean, it's people making an aesthetic statement. It's people saying like, look, we are in some sort of a strange dystopian future, and that you don't have to obviously buy into that. It's someone making an artistic expression. But when you take a look at that, you go, how do I represent this? Like, how do I represent this as a thing that I'm experiencing as a person in California? Or, people who have lost their homes, people who have suffered through COVID-19 and now they're suffering through the fires, people who are getting hit by COVID-19, social injustice, and the fires. And it's like, this right here is a massive amount to represent. So there are choices in how we take data and how we represent that data. This is really important. And when I think about things like, there's this topic of social isolation, which is such a huge topic. I mean, how do we internalize social isolation? I wanted to diagram a few things, to schematize a few things. And there are all sorts of bits of data about social isolation, the various activities that we have with social isolation. Some of them are, let's say, kind of a little bit silly. And so this is one example, the interest over time and what people are actually searching for. It's like how to use Netflix, how to cut your own hair. And this is, I'll be honest with you, it's something that I've been doing since I was maybe like 11, actually. Home workout, antiviral. That's it. This is an important one because one of the things that most people actually don't know is that you can actually use these search engines as ways of organizing big data. When people use this term big data, it's kind of a really tricky term. This is just a high, like imagine a super high volume of data. That, I don't know why I put an I in volume. It does not have an I, but just imagine this is like, maybe a French spelling or something like that. So when you have big data, what you're really looking at is a massive volume of data where you might actually not really know the relations. A lot of times the relations are unclear because there's so many variables. Imagine the amount of variables that are floating in here. However, big data often allows you to make really accurate predictions about things. And when the swine flu happened in 2008, this is one of the large things that happened, is that the CDC data could not accurately predict the expansion of the swine flu until about 2 weeks after. So you were getting this prediction of the outbreak, if there was one, about 2-3 weeks after, but then Google was actually producing accurate results based on what people were searching for. So when people search for things like antivirals or when people search for things like symptoms, what's going on there is you are actually tracking in live time people who are potentially concerned and they're not going to go to the doctor. So you're getting this, imagine, like a large data set that tells you where an outbreak is actually emerging and how that outbreak is continuing. So it's interesting because, this data is obviously mostly silly, but there are things that are really useful in how you take data and how you use things like search engines to take data. I mean, really think about this. Like, how could we apply something like this in terms of cognition? Think about what people are searching for. So search histories that have to do with people experiencing anxiety, loneliness, depression. These things are absolutely necessary to track. And these are things that oftentimes we are not tracking. So we're concerned about things like predicting, let's say, the physiological outbreak. So predicting COVID-19 as a function of, let's say, SARS-CoV-2 infections, and COVID-19 is going to be the inflammatory response that we're really concerned with. We're concerned with tracking things like this, but how about tracking things like social withdrawal? So other examples, this one right here, someone did, this is also, it's kind of silly. This is an example someone did of their relative that started messaging them. This is before, you're taking a look at before and then after social isolation. And here what we see is that people are reaching out to people, at least in this example. Some people might actually stop reaching out to people. It's a really tricky thing. But in this example, people are reaching out to people more. People are trying to connect more. And this is something that indicates something. And we want to know, like, well, what is the cause here? What is it that people are feeling within this environment of social isolation? It's an environment that is all around us. I mean, we're all feeling this right now. And it's somehow very different to interact with people via Zoom and sometimes having even a constructive conversation, a friendly conversation. I mean, I've had so many Zoom calls where people just want to high five over Zoom, and I'm like, I don't think, it's like not a physical possibility, but let's just do it anyway. And it's like an 80 Zoom high five. So this is awesome. This is a classmate example that I wanted to go through. And when we talk about, number one, the specificity of variables, number two, the specificity of relations, and number three, picking and choosing things, there are so many good examples out there, and you should definitely take a look at the discussions. And I think that the thing that's really important for me is that you all maintain choice in your topic. I want to make sure that I do not tell you what is a good topic, what topic you should focus on, because in previous iterations, as soon as that happens, everyone just kind of ends up, like zooming in on a particular topic, and everything ends up looking like a replication of everything else. Right now, the topics are super diverse, and I want to make sure I continue it. My purpose is to mediate this process. It's really to give you freedom of creation, make some suggestions, make you think about things. I'm going to give you access into my methodology, how I think, how I reason through stuff, and I'm going to give you cool examples along the way. So one of the things that I really like about this is there are a ton of variables here. All of them are specified, and there are a ton of relations here also. So let me start by looking through this right here. And what I'll do is I'll do a quick zoom in. Nope, too much. Let's just cut that. All right. And let me just read through the description because the description is really important as a precise guide. This diagram shows that therapeutic gardens and indoor plants have multiple effects on elderly people. Okay, good. So this is what we're starting with. We want to know, remember, is it their participation in therapeutic gardens? Is it just having a therapeutic garden around? So something like an indoor plant is a thing that exists. It's just there. Imagine it as an object or maybe an artifact. And people talk to their plants for sure, which is actually, I mean, it's supposed to make them grow faster. There's all this cool stuff we don't know. But imagine therapeutic gardens as something like an activity. When you have an activity element, somehow the cognition becomes more dynamic. And so we want to know, obviously, multiple effects. And there's a particular, and these are going to be the effects. So the effects are all going to be, let's say in this case, it's a list of like 5 or 6 variables. And we want to know a particular population. This is really good specificity. They reduce feelings of depression and loneliness in residents that are struggling to adapt to their new living circumstances. This is, I mean, it's just such a beautiful thing that scientists study this kind of stuff. This is the stuff that we need to understand is when someone feels uncomfortable in a new place, it's not something that you're supposed to get over, you're supposed to repress or forget or something like that. Something that people are supposed to understand. What happens when you enter a new built environment? I mean, it's something that we think is highly important when it comes to ecosystems, when you transport a species from one area into another area, and those interactions change. So we should really care about how humans interact with new built environments. The houseplants are companions to the residents and they make the residents happy. And this is cool. There's a citation right here. Therapeutic gardens have given residents the ability to spend time in a natural environment. Residents with dementia have shown a decrease, this is good, in disruptive and agitated behavior. So notice that we have information about how we are measuring or how data is being produced. We are looking, let's say, generated. We are looking at some sort of a behavioral cue, agitated behavior. So this is important because we can also do something like an fMRI. We can also do things like surveys. We can take blood cortisol levels. There are all sorts of ways that we can understand or operationalize agitated behavior. The garden seems to have a calming effect on them. Also, therapeutic gardens may bring back memories in residents with dementia. This is really cool. So it's like, what are the causal processes responsible for neurotropic effects? What are the things that we can use to influence memory as a dynamic mechanism? One of the topics that we're going to talk about later is that memory formation is not just a simple, computers aren't simple. I was going to say simple thing like a computer system. Computers are massively complicated. But it's not like a computer storage system. It's actually a system that is highly sensitive to both the physical and social context that you find yourself in. You can change how people form and reform their own memories, which is like such a cool process. So we want to know what are the causal conditions that are responsible for this. Lastly, therapeutic gardens and indoor plants decrease cognitive stress. The residents are more relaxed and feel under less stress. So here, let's just direct our attention to the diagram real quick. Again, props on the specificity. And the challenge for us is like, look, we make something specific and then we want to know, can we make it even more specific? And this right here is cool because we go, okay, so here are therapeutic gardens and we want to know if it's just a presence. Imagine this is something that is static, so just the presence of a plant. Or is this something that is an activity? And we need to know what type of an activity. So this is where we can specify further. We can say, okay, well, this type of activity is something like if you participate for 1 hour per day, this might be a lot, but 1 hour per day in a particular type of gardening activity. And that is specific enough. Now, this is really cool because we have multiple variables here like depression, loneliness, and sometimes these things can overlap, but it's really important to understand that we can have multiple psychological phenomena and they might not overlap fully. So, feelings of withdrawal, feelings of loneliness might not perfectly correspond to depression. There might be anxiety, there might not be anxiety. There might be some sort of a feeling of hopelessness, and in depression might be a little bit different. So, we have to specify these as well, and we can specify them based on, let's say, how people are using these terms in the DSM-4, the DSM-5. Let's say that's one way to operationalize it. We can also look at how people describe this qualitatively. Qualitatively. And when people describe an existential state, I mean, this is like something that we should be talking to people about all the time. And this is if you're a philosophy major and people go like, oh, what do you do? And you're like, I'm a philosopher. And they're like, oh, no. And then you start talking to them about existentialism and authenticity and all this cool human stuff. And they're just like, I don't want to hear about that. Let's talk about creating an app or something. And it's like, that's just the boring stuff. So when you ask people about their qualitative states, I mean, there's all this cool stuff that you can really explain that might not be coded in something that is modern day cognitive behavioral or modern day clinical psychological. So when I brought up the term previously, something like the sublime or something like the feeling of dread, those things are highly complicated phenomenological states. Cognitive stress, another one. So this right here is the stress something that is has a behavioral output? Is it measured with some sort of a blood test? Is it measured by a brain scan? What's going on here? And same thing with memory is how are we tracking this? Is it their ability to remember a previous experience? Is it some sort of formation of a new experience? Is it short term? Is it long term? And this is what the really cool part of memory is. Memory is constantly, as you'll see, reconstructed. Something's going on with my spelling today, or like all the time. Memory is constantly reconstructed, and what this means is that memory changes. Now, in the research, are scientists looking at how memory changes in these people? Because memory change is actually a really good thing that indicates that there's protein building that's happening. So when memories don't change, you might not have the same type of protein building going on. So the reconstruction process is an important one in anxiety agitation. We saw earlier that this was something that was a behavioral measure. So we can specify these variables based on, think about this as we create characterizations, we create definitions, and the literature that you're working with is going to give you these definitions. You just have to specify exactly what's going on here because cognitive stress can be measured in a number of ways. And then the next thing is, so we talked about specifying exactly what we're talking about, the static plants or the activity of gardening. We talked about the cognitive variables on this end. And this is what's really cool is we're talking about things like something reduces something, something decreases something, something boosts something. And we want to know exactly how this works. So, for example, is it changing some sort of an endocrine function? Is it changing some sort of self-reported mood? What exactly is increasing? And so you can think about this as when you specify the variables on this end and you specify the variables on this end, as a function of that, you should also specify the relationship here. And there are a ton of ways that you can talk about this relation. You can talk about things like production, but you can also talk about, this is something that is oftentimes seen in scientific diagrams, activation. And activation is oftentimes indicated by this type of arrow. So when there is some sort of activation versus when you have something like, and you'll see me use this symbol also, inhibition. And it's really cool because you might actually have certain kinds of causal processes that will activate a particular set of things, and then you'll have other ones that will actually inhibit those things. So now you're working with multiple variables, and each of these variables do different things. So I want you to keep an eye on when you have, let's just represent this very simply, you might have multiple variables that somehow work together to produce an effect. And this is kind of a cool thing. Imagine that you're talking about activation. Okay, so I'll just put A for the relationship of activation. And you're talking about two variables here. Let's say variable 1, variable 2, variable 3. This is going to be some sort of effect that you're looking for. Now, you can have an activation that is an OR activation. So this right here is an OR activation. That means that one of these variables, at least one of these variables, will be causally responsible for producing this effect on variable 3. But then you can also have something, and I don't expect for you to really master this yet. Wow, that was a big mistake. So please don't feel pressure to use these OR and diagrams, but you can also have it where both variables, this is an AND symbol, will produce this effect together. And sometimes we know exactly in what way each variable is involved. So let's say like you need 20% of this and it's going to do something, and then 80% of this variable and it's going to do something. But sometimes we don't know. Sometimes that interaction, so think about, we know that both of these variables are, let's say, necessary and sufficient, but we don't exactly know what's going on within this interaction. It's a black box. Like, we don't really know how the combination of these two things will produce this third thing, or will create this effect that we see on the third variable. So sometimes we know that both are, let's say, necessary and sufficient. So necessary, you need both of these variables in order to produce this effect. Sufficient, together, so they're jointly sufficient. Together they produce this effect. But we don't exactly know how. And this is the kind of picture that I keep on pushing, is we want to know how something on this end is producing something on this end. And we have to specify as much as possible. But if that's way too complicated, let's just chill for a second, because I think what's really important is that we're learning new things in very small steps, and we're learning how to diagram. We're taking a look further at our examples, but don't feel like you have to do a massive, perfect diagram. It's always a work in progress. I'm going to write that out. Work in progress. So don't feel pressured to have a perfect diagram. So just like we can have and or combinations here, we can also have and or inhibition. So I'm just going to do this symbol right here for a second. So you can think about this as two variables working together. They can inhibit this third variable. So think about what is activating or inhibiting what. I think that's like a really cool thing to think about. Okay, so check this out. Let's see if we can maybe diagram something like this. Let's not go here. Let's go here. If you're talking about, let's say, social isolation is kind of it's a big topic. There's a lot of stuff that's going on in social isolation. So if you wanted to, just kind of put at the top, and let's just go back to, all right. Let's say you're brainstorming about this topic and you're like, what am I going to look at? Like, how am I going to break this stuff down? Let's just start somewhere in the middle, and let's talk about this weird phenomenon of, so we want to know, let's just say that this applies to the elderly. So we want to make sure that we protect the elderly population. COVID-19 seems to have a devastating effect on people over 65. And what we're seeing in the hospital setting, let's just start with like a little bit of data that might be useful for us. We're seeing this thing, delirium, states of confusion of people who are experiencing COVID-19 in the hospital, And what we have here is 1/2 of hospitalized older adults experience this state. And so, how this is important when you say something like delirium, how are we operationalizing it? What is the definition? What is the characterization? Let's just say that we're talking about some sort of state of confusion. We can specify it further. And what's really important here is that this type of delirium right now is being tracked as being a major risk factor of dementia. Now, dementia is a really complicated phenomenon. Excuse me, that's supposed to be phenomenon. When you're talking about dementia, when you're talking about particularly Alzheimer's dementia, there are a ton of causal factors here. So one of the large research projects that I spent about 3 years working on is the particular causal factors for Alzheimer's dementia. And there are so many different complicated biomarkers for Alzheimer's, and how the causal story works was really convoluted for a very long time. So one of the things that I did was I tried to clarify those causal mechanisms. And one of the big things was neural plaquing. And it doesn't matter exactly what type of neural plaquing for our purposes right now, but the causal factors for neural plaquing were seen as things like genetic, were seen as things like environmental. And then somewhere around, I think it was 2017, this rogue group of scientists were like, well, one of the big, let's say that you're talking about plaquing, and let's say you're talking about things like Alzheimer's dementia. And this rogue group of scientists, while we were looking at the particular type of plaquing, let's say, it's like 1, 2, there are all sorts of ways that we can talk about plaquing, and also all these, we were kind of looking at all of these complicated biomarkers, and these biomarkers are things that you can measure in people to predict whether or not they have Alzheimer's dementia or what their propensity is. So there are all sorts of, we were looking at the causal details, and it's even more complicated than this. And this rogue group of scientists were like, you know what? What's really important here is the kind of infectious disease that people are exposed to. So it was herpes simplex virus. It was also certain kinds of bacteria, and that these were actually causal factors responsible for the important type of plaquing that we were looking at. So again, the reason why I'm giving you this picture is it's really massively complicated to talk about dementia, and when you're just looking at the plaquing side, it's way complex. So now if you're taking a look at things like how delirium produces dementia, this is a completely different thing. So it could be that delirium produces dementia, and this has something to do with the oxygen conditions. So imagine people with COVID-19, especially if they are placed on respirators, there's compromised oxygen exposure, and what happens is the production of delirium. So if you have, let's say, limited, in this case, limited oxygen conditions, it can actually activate this state of delirium. So one of the important things is how we specify each of these, but it gets way more complicated. So check this out. One of the things that they found is when you're thinking of, okay, like how would I make a difference? How do I, let's say, minimize delirium and then minimize the risk for dementia? Well, one of the things is you can clearly change the oxygen conditions. So what you can do is you can increase oxygen conditions. And this would be a difficult thing to do, especially in the case of COVID-19. I mean, this is what medical professionals are struggling with. So if you were to successfully change this, you would somehow inhibit delirium and you would somehow lower the risk factors for dementia. That's one of the things. In other medical interventions, so let's say that these are medical variables, and you'll see why I'm doing this in a second, because it's like, well, why are we focusing on the medical variables? Because I want to show you that intervening in the medical variables can be equally, what am I even saying right now? It can be equal to intervening in built environment variables. Sometimes you just get caught up. Okay, so one of the things is oxygen conditions. And then the other thing is you can take pauses in sedative medication, so you can interrupt sedative medication. And what this is going to do, remember, it's going to inhibit. These medical variables are very important, but equally important is a built environment variable. And this is something that they're finding. So imagine this as a built environment intervention. One of the things that they're finding is that if you continuously orient the patient towards their surroundings, it has a massive effect on decreasing delirium and also decreasing their risk factors for dementia. So if you are orienting patients to their surroundings, I mean, think about how important this is to do with people in general. I mean, this is one of the mechanisms for activating protein synthesis in the hippocampus, is you are continuously orienting people spatially. So this is a great, simple, difference-making built environment intervention. So we can take these medical interventions, we can focus on that side, but we can also focus on the built environment side. But notice here that we are drastically limiting the conversation, because you might think like, well, there's all this other stuff that people can do. Not only can you orient patients to their surroundings, you can also add things like nature to their surroundings. And if you add things like nature to your surroundings, this is an important thing that decreases the risk of dementia directly. You can introduce people to beneficial microorganisms that can decrease the inflammatory response. You can somehow, so nature here has these biotic elements. Well, what are those biotic elements? You have good bacteria. You also have things like sunlight. From sunlight, you get vitamin D, and vitamin D is actually, they're finding it super important for things like promotion of ACE2 receptors, and this right here seems to be the way that people get infected by SARS-CoV-2, but it also seems to be really important in combating SARS-CoV-2, and people who can't produce proper ACE2 when they have SARS-CoV-2 get this hyperinflammatory response. So vitamin D seems like it's important for, let's say, minimizing inflammatory response that might actually influence dementia. You see how we're getting so complicated? You might be like, slow it down, it's too complex. I know, this is how my mind always works. Like, I'm doing diagrams in my mind probably all day. Who am I? But you have to think there are all these variables, and what we're saying is slow down. Let's work on those later. Like, forget about these relations. Yes, they're super important, but there's a lot of other stuff that we have to specify. So when you think like, should I include more variables? It's like more variables, and then you think like, slow it down, man. Like, you gotta get super chill. Put some vaporwave on and just chill out for a second. Okay. The other thing that I wanted to say is, when you're talking about things like delirium, so let's say, you're looking at isolation in the elderly, and when you're talking about things like the risk of dementia as a function of the built environment, well, there's all this other stuff that it could amount to. One of the important things that people are talking about side by side with delirium is actually PTSD. So there is a connection between PTSD and delirium, but there's also this connection, this is really important, that PTSD often produces memory impairment. And when you're talking about risk of dementia and memory impairment, these things overlap. So we have to figure out, okay, well, what's the relationship here? And one of the ways that we figure this out is we specify what's really going on here. Is it that the delirium is somehow being produced by these low oxygen conditions, or is it that the total experience is so traumatic that it's actually a PTSD promoting experience? Or maybe it's both. So again, we have to specify. Now, the other thing, you can take a look at this over here too, people have studied just social isolation. There's a lot of stuff going on with the science of social isolation, which can overlap. So, social isolation, not having a proper social support system, can overlap with PTSD. And in this case, what they're finding is that social isolation can actually also produce, we'll just put ME for memory impairment. So, imagine this is a total overlap. So, you might have this partial overlap with post traumatic stress, but also this total overlap um, with memory impairment. And one of the important things is like, well, how does this work? Because we want to know what are the mechanisms that are involved here. It turns out one of the key mechanisms here, and you could probably see this coming, is stress. Stress actually activates pro-inflammatory responses that change our gene expression. I mean, this is like devastating stuff. When you experience stress, it's not something where it's like, oh, okay, it's just stress for a little bit, or let's say it's stress that's long term, and people think like, oh, it's somehow the stress itself and the presence of the stress is the thing that is shutting down our immune system for the time of the stress. No, it's actually that when the stress stops, the meta markings on those genes, the gene expression actually changes, and the function of inflammation totally changes within your system. So the pro-inflammatory mechanism of your system fully changes. So what I wanted to do overall here is just to show you how things can get super complex, way more complex than necessary. And now it's good as a large scientific model that, let's say, we take years to develop to show how social isolation and PTSD are related, and how PTSD and delirium might be related, and all of the various connections between physiological variables like oxygen conditions, and then things that are complicated sociological and also physical variables within the built environment. So in this case, some sort of an activity, constantly orienting your patient towards their surroundings. So if we had years to work on it, we could know how these things are related. But in the meantime, what we should be doing is isolating. So maybe we just want to look at something like this pathway, how a simple built environment intervention changes delirium and changes the risk of dementia. And we block out all the other stuff. I mean, all the other stuff is super important, but we just block it out. And I'm just going to go back to this initial diagram. So the suggestion was to limit the variables when you're attempting to represent the world on the model side, and then to limit the variables when you're looking at scientific measurements. You're not doing your own measurements. So imagine this as the measurement side or the data side. And this is the final step that's really important. You can't just take data and have a certain kind of explanation. The way that science works is you have to generate a precise prediction. And I want you to be on the lookout for predictions, because a model is going to explain how things are. So imagine that a model represents how things are in general. But a prediction is more specific. It's what we expect to see if the model is adequate. So, for example, if someone gardens 1 hour a day for 3 weeks, what do we expect to see? If we create classrooms that have sunlight, or classrooms that have biotic elements, or classrooms that allow all the cool campus cats to come into them, like, that is awesome. We can make a specific type of prediction about things like cognitive variables. And what's really important about the scientific process, this is where we kind of go back to how scientific methods work so that you all get a larger view of what's going on in cognitive science. We match up the data, which is a particular, let's say it's a particular observation. And that observation is what you do see. So we match up what you do see with what you expect to see. And if there's a match, So imagine that there's this match. Then you actually have evidence that your model adequately fits the world. So your model does a good job at explaining, predicting. So you have evidence that your model adequately fits the real system that you're talking about. And let's say there's no match. So you take a look, you make a prediction, you don't see it fit. This happens oftentimes. And I mean, think about this. Like, think about this in the case of ergonomic chairs, or however you say that word. I think some people are working on some really cool, funky examples. That is something that is a major feature within our built environment. People have standing desks. Some people do like balance boards and treadmills and all sorts of stuff while they're trying to work. It's really an amazing kind of thing how we've modified our local work environments over the decades. And people had these predictions like, oh, this will be totally great for you, but in actuality, it's something that produces herniated discs or cognitive agitation or full burnout. So imagine that you're trying to do like CrossFit while you're typing up a paper or something. Like, this is just too much stuff sometimes. You know, sometimes you just got to chill and just simplify everything and just do the thing. And I think that all of these ways that we intervene within our built environments, whether that's producing a certain type of UV radiation or changing our workstation or our activity or whatever, sometimes those predictions don't actually get realized in the data. And we see that it's a completely failed thing. So when there is no match, what you change is, it's not that your model is false. You don't say your model is false. You actually just say, look, there's currently no evidence. Maybe in the future, you know, we'll find that something like sitting on a Bosu ball is actually really important for learning. I don't know. But right now, there is no evidence. And I wanted you to see this because I think that this general picture of scientific methods gives you a way to locate where you can specify. And for our purposes, the specification is really going to be on the model side, and on the data side, you want to limit your variables as much as possible, and you want to look at really simplified relations. But keep an eye out for the fact that oftentimes this stuff is decided by matching a prediction with an observation or some sort of intervention. All right, everyone, I will see you next time for more specification, more reasoning, more analysis. Have a good one.